Well, hello, my name's Kyle Moody. I work with a company called ICM as a control system specialist, and these are some of the strategies that I've learned to help reduce unplanned downtime. Quick summary of what I'm going to kind of go over. Go a little bit about ICM because I'm sure none of you in here really heard of ICM before. Then I'm going to go into a summary of my problems that we've faced in some of our plants and our plant designs. Then the solutions and some of the benefits we've noticed from implementing those solutions. So who is ICM? ICM is a global company based out of a small town of Colwich, Kansas, just outside of Wichita, Kansas. It's a biofuels technology company that works mostly with ethanol production. And we're constantly developing new technology to improve ethanol production, whether it be full plants or bolt-on technologies to add on to older plants to help improve the production of their ethanol. Some numbers for you. ICM has developed, designed, and built over 108 plants throughout the world, mostly US and Canada, but some in South America. 1/3 of the world's ethanol production is in some way, shape, or form influenced by ICM technology throughout the process. We have over 400 dryers installed in over 150 plants, and not just ethanol production facilities, also other alcohol and other industries as well. And we have 18 non-ICM plants that have been retrofitted with ICM technology to boost performance and ethanol production. And one of our main missions is to provide innovative solutions that sustain agriculture, increase feed technology, and advance the research and development of renewable energy. And as a control system specialist within ICM, I work mostly in the engineering and aftermarket services, but we also work with manufacturing of things like our dryers, our conveyors for those dryers, and technology development. So some of the main issues that I've run into that have caused downtime, I'm going to focus a lot on South America because that's where I've been working recently, and that's where we've had a lot of issues, bigger issues that have happened. And the three biggest issues that I've run into of power stability, servers, whether it be hardware or software issues, and also communication setups. To combat some of our power issues that we've had, if you think in a rural area of the US, you have occasional brownouts, maybe a blackout every once in a while. In the areas that I've worked in South America, you can multiply that by 5 or 10 times. It's a constant issue that we've run into of brownouts of different sections of the plant and things like that. So we've implemented some solutions like in some of our US plants, we just have simplex systems for power. But in South America, a lot of our systems, all of our control cabinets, all of our remote I/O cabinets, we all use redundant power supplies that have dual feeds to each of these panels. So if you have a brownout, maybe on one breaker, you still have a second power supply and keep your I/O running, keep your valves running and things like that, keep your plant running. The other big thing that we implemented a lot more was UPS and backup batteries. And all of our controller cabinets, our remote I/O cabinets, our servers, and our clients. Now, you have a short brownout or you lose an MCC, you still have control of your plant, you still have your HMI running on your clients, and you still have your servers running, so you still can open valves and close valves. If it's a short brownout, maybe to help keep a tank heated, you can keep a steam valve open, things like that. The second biggest issue that we had was server issues, whether it be hardware issues or software issues. On some of our original plant designs, when it came to the DCS, we would have 4 physical servers. One would be our data HMI server, one would be our historian server, one would be for our operator clients, and one would be for engineering for diagnostics and things like that, and development and programming. The issue with this is if you lose your data HMI server or you lose your operator client server, you lose control of your plant. You're running blind. And for some customers, they don't see that as an issue. So for some of our plants we have built with the simplex design, But for South America and a lot of our bigger customers, they want to have no unplanned downtime. They don't want to lose control of their plant. So the two biggest things we've implemented are Stratus servers and redundant VMs or VMs that'll run side by side. What Stratus servers have helped us do is to really get away from having any hardware issues because of how they run. I'm not sure if you're familiar with how a Stratus server runs, but they're fault-tolerant servers. You'll have two servers running side by side, and they run in lockstep. So if you have any issues on one of the servers, so let's say a hard drive's malfunctioning, you don't lose any time when it switches over and using the other hard drive and keeps your VMs running. The other big thing, like I said, was redundant VMs. So we started using redundant data HMI servers. So if you had any software issues on that virtual machine, let's say it locks up or has communication issues, you can switch over to your other HMI data server and not lose any data. Also having two operator client servers that are run side by side, where you have half of your control room maybe running off of one client server and half of your control room running off the other. If one of those has some software issue where it locks up or a memory leak, you can restart that. You may lose two clients, but you'll still have two clients running on your other server, and you don't lose control of your plant, and you keep running. The third biggest issue was communication. On a lot of our original designs, we would use only one switch that would connect together our controllers, our servers, and our clients, which caused a lot of issues in some plants where you lose that one switch, you lose everything. You lose all your communication, you're down. And for more of our modern designs, we'll have two switches with redundant NIC cards on your clients, redundant controllers with two different communications cards, and your servers will have two sets of communication. So you have half connected to one switch and half to the other. So if you lose one Ethernet connection or one switch to any of these clients or servers, you still have a communication path and you still are getting your data and you're still controlling your plant. The other big thing that we implemented that a lot of DCS systems will suggest, but people don't always do, is redundant network topologies. Now, this is a very simple one that's used quite often. It's a ring network. And what a ring network does is, as you can see in the picture, that let's say each of those green dots is your remote I/O cabinets in the field. You can lose any one of those lines and still have a communication path to all of your remote I/O, all of your valves and everything of that nature. And I've seen it proven time and time again where we'll be finishing up part of the construction of a plant and start running part of the plant, but we'll have construction going and someone digs into a fiber line and we lose one of these. We still keep running and just get an alarm saying, hey, there's a problem between panel 3 and 4. I can't communicate between these two panels. And so you have time to fix that and not lose any runtime and not have to go down because of someone digging where they're not supposed to or something like that. And just some benefits that we've noticed with running fault-tolerant systems. Each area of the plant, if designed properly, each area of the plant can handle a single point of failure and usually have fast recovery times from these single points of failure, fast switchovers and things like that, and also time saved. With the industry that I work in with ethanol plants, if you're down for more than a couple hours, you also have to factor in for downtime the time it takes to bring the plant back up. Tanks have to be reheated, distillation has to be reheated, which can take time, and then as you start to feed again, you also have to heat it back up some more, so your 6-hour downtime for replacing a switch or a server suddenly turns into 8 hours or 9 hours because of the 2 or 3 hours it takes to reheat the process and get it going again. And the other big benefit that we're all kind of here to hear about is longer uninterrupted production time. So less unplanned downtime and able to run with one fault in certain areas. Thank you.